This will be a two-part talk on the winter season outlook for Central Region. The first presenter will be Megan Jones, and the second presenter will be Jeff Boyne. Go ahead, Megan.
Thanks, Mike. Hi, everyone. My name is Megan Jones. I am from the National Weather Service office in Bismarck, up here in North Dakota. I'm also the climate services lead, so that's how I got involved with all of this. Just so for a little background information, my talk as well as Jeff's talk, and he'll talk a little bit more about this, was part of a small group in Central Region where we were working on creating resources in that subseasonal to seasonal time frame, just to make some information resources available for people in Central Region. Those are all available on the Central Region Climate Services webpage. That's where this presentation as well as Jeff's presentation will be linked. So I'm going to talk about some implications of El Nino on Central Region, a little bit of background on El Nino, as well as what we can typically expect, and then Jeff is going to go into more detail on this year's winter outlook. So just to get started on what exactly is El Nino and really what is ENSO. The El Nino Southern Oscillation is this recurring climate pattern where there's a connection between the ocean and the atmosphere, and it really involves the temperatures of surface waters in the central and eastern tropical Pacific. That's the ocean part of it, and then it's also related to sea level pressure, lower and upward level winds, and tropical rainfall across the Pacific Basin, and that's related to the atmosphere part of it. So really, it's on this period ranging from about 2 to 7 years. These surface waters are going to be warming or cooling from anywhere to 0.5 to 3 degrees Celsius compared to normal. And there's two phases to this, these two extreme phases. One is called El Nino, that is the warm phase, and then the cool phase is La Nina. If it's in between these two phases, it's just called ENSO neutral. That's when the sea surface temperatures are pretty close to normal. It's an irregular oscillation, so it's not, one after the other, very, very typical, but it really will affect rainfall distribution, not only in the tropics, but it also has a really strong influence on weather across the United States and the rest of the globe. So a lot of implications with this one climate pattern. When we're talking about normal ENSO conditions, normally what we have is we have these strong trade winds blowing from the east along the equator, and those are going to be pushing warmer water into the Western Pacific Ocean. So we end up with those warmer waters over in the Western Pacific that then leads to rising motion, and you get the first half of the Pacific Walker circulation. You're going to get rising motion, more rainfall and convection over that part of the Pacific. By the time you get into the upper atmosphere, you're going to have then those westerly winds completing the other half of the Pacific Walker circulation with then sinking motion over the Eastern Pacific. If we zoom in a little bit, looking more at the ocean waters from Indonesia to South America, you can see that there is this, the warmer waters are over in the Western Pacific. Again, we have those easterly trade winds going into Indonesia where that warmer water is. You then have that convection over the Western Pacific, and then you have your Walker circulation. And this is just the base ENSO neutral state. When we're in a La Nina, which we've been in for the past 3 years, it's just an amplification of this ENSO neutral state. But when we are in the El Nino phase of ENSO, things look a little bit different. And this is when those trade winds going from east to west, those weaken, and then we end up with the warm waters more in the central and eastern Pacific Ocean instead of in the Western Pacific Ocean. This means that we don't have our typical Walker circulation across the entire Pacific Ocean. Instead, we end up with easterly winds in part of the Pacific, and then we end up with westerly winds in the Western Pacific near the surface of the water because we have this warm anomaly in the Central and Eastern Pacific. We then end up with that convection over the Central Pacific. So the tropical rains that usually fall over Indonesia have shifted eastward. And then we have our convection central, and we end up with a different sort of circulation compared to the normal base state, which does end up shifting the subtropical jet stream to the south as well, which really has implications for what we see over the continental US. Again, looking at a zoomed in view, you can see that those warmer ocean waters, which are normally over the Western Pacific in the ENSO neutral base state, have now shifted, and we have much warmer water over the Central and Eastern Pacific. And again, instead of having those easterly winds across the entire equatorial Pacific, instead they go over part of the way into the Central Pacific, but we have that convection over the Central Pacific instead of shifted further west like it normally is. So when we're looking at sea surface temperatures, there's a process for determining what sort of phase we're in. CPC has really determined that we look at this Nino 3.4 region as kind of the most representative. So they're looking at these sea surface temperature anomalies over this specific region of the Pacific, and then they're going to be comparing that to average to see if it's warmer or cooler, and that is one of the steps in determining what sort of ENSO phase we're in, if we're in an ENSO phase. So they look at the sea surface temperature in that Nino 3.4 region. It's calculated for each month. And then that's averaged with values from the previous month and the following month. So we're never looking at just one month in particular and saying, oh, this is El Nino or La Nina. This is a 3-month running average that is then going to be compared to the normal sea surface temperatures from our climate-based period of 1991 to 2020. And then that departure from average is known as the Oceanic Nino Index, or ONI. And then the NOAA operational definitions of El Nino and La Nina are based on ONI. So that's kind of how we go from the sea surface temperatures to getting the anomalies to getting the ONI, which is what El Nino and La Nina are based on. So then we have our operational definitions. The El Nino is characterized by a positive ONI greater than or equal to positive ½ degree Celsius. The La Nina is characterized by a negative ONI less than or equal to negative ½ degree Celsius. And again, whenever the ONI is between these two values, so less than plus or minus ½ degree Celsius, conditions are referred to as ENSO neutral. We have this nice flow chart over here on the right. This came from the ENSO blog from climate.gov. If you've never been there, it is a great resource. They're always putting out really interesting and useful articles with a lot of great illustrations as well that I've used with a lot of outreach. They do a really great job of simplifying a lot of these concepts. But so this flow chart shows, how it's determined if we have El Nino conditions or not. We start over here at the top. Is the monthly Nino 3.4 sea surface temperature at least ½ degree Celsius or greater, either yes or no? If it's yes, we go into the next step. Do we think that Nino 3.4 sea surface temperature will stay at that threshold for the next several seasons? So again, it's not just one season and we go, oh, okay, we're in an El Nino. We are, if we're expecting these El Nino conditions, we want them to continue for the next several seasons. So if that is yes, we then switch to what the atmosphere look like. And that's kind of the third part of this, where again, this is a coupling between the ocean and the atmosphere. So we do need to have that atmospheric response to really be in El Nino conditions. If there's not really good indications of that weaker Walker circulation, we're not going to be in El Nino conditions. So what we need indications of that weaker Walker circulation, which is more rain over the Central Pacific, less rain over Indonesia, because we have those weaker easterly trade winds, and we kind of shift where we're seeing that convection. If we have these three things, then we are going to be in El Nino conditions. That really ties into the ENSO alert system, which is kind of the final step in this. The El Nino or La Nina watch will be issued when conditions are favorable for the development of El Nino or La Nina conditions within the next 6 months or so. Then we go to the advisory, and this is issued when conditions are observed and are expected to continue. That's the second part of that flow chart, is not only do we have those sea surface temperature anomalies at the moment in that 3-month running mean, but we're also expecting that to continue for the next several seasons. Then that final advisory will be issued after conditions have ended. And then if it's not active, that means that we're just kind of in ENSO neutral and we're not expecting anything one way or the other. So right now, of course, we are in that El Nino advisory. We are observing El Nino conditions, and those are strongly favored to continue through the winter and into the spring. So for timing and impacts from El Nino, the strongest impacts to North America are in winter. This always comes up when we're talking about the winter outlook. Even if, in the summer we were already talking about El Nino, but really it becomes the focus of the winter outlook because this is when El Nino is at its strongest. We see those strongest impacts. The jet stream that affects the North American climate is at its strongest and its most regular pattern. And as we'll show here in a little bit, can really determine the typical impacts that we see across the continental US. These events for El Nino typically last 9 to 12 months. They can last for up to 2 years. And again, they don't occur on a regular schedule, typically occurring every 2 to 7 years on average. And they do occur more frequently than La Nina. But again, I think, we've seen the past couple of years, we were in 3 La Nina winters back to back to back, and then suddenly flipped to an El Nino. So certainly not a regular pattern that we can expect, but there are, a typical cycle that we see with this. If you want to do some real-time monitoring, the Climate Prediction Center webpage has their monthly ENSO diagnostics discussion. That includes the official ENSO status, and it's published the first Thursday of every month. You can actually get these emailed to you, and I do that. Just kind of helps keep me on track with when their discussions are coming out. They also do weekly ENSO updates that are updated every Monday. And then IRI CPC has a bunch of plumes and charts. They have a lot more ensemble and probabilistic data that's available that, again, if you're doing a little bit deeper dive into ENSO, some really useful resources on these web pages. Just some quick kind of a little bit more sciencey information, just because I heard this actually come up in the past couple of months. There are different flavors of El Nino. There's the normal Eastern Pacific El Nino, which is more of the conventional El Nino that we see, where the strongest sea surface temperature anomalies are in the Eastern Pacific. And then there's the Central Pacific El Nino, which is also known as Modoki, which is probably how a lot of you have heard this. That's where the strongest sea surface temperature anomalies are in the Central Pacific. And it's interesting because we don't typically talk about it being one or the other too much unless you're like pretty deep into ENSO forecasting and things. And CPC a lot of the times won't specifically note this in their forecast, whether it's one or the other. But if you read their discussions, sometimes they do talk about where those anomalies are the strongest, which can give you a hint of what it's looking like, at least at the moment. It also gets tricky because it might be a continuum and not just one or the other. The location of sea surface temperature anomalies can shift around within the span of a single El Nino event, especially if it's a little bit longer duration. So a lot of times it's not just cut and dry one or the other. There is some research that shows that typically these Eastern Pacific El Ninos do tend to be stronger, whereas the Central Pacific El Nino tends to be the weaker El Nino. So with this year, we are, I think right now, at a 75 to 85% chance of a strong El Nino. So would expect more of this conventional El Nino that we will be seeing. So of course the question then becomes, why do we care so much? I know up here in North Dakota, obviously we are pretty far from the Pacific Ocean, so you kind of have to ease people into thinking about, why we care about this large climate pattern. And really it's because it is responsible for a lot of variability. And so explains up to 38% of monthly and seasonal variability, according to the CPC. It might not be the strongest influencer in all areas, especially depending, on the season, where you're thinking about just winter or one of the transition seasons. But it explains a lot of the variability we see. And it's also really predictable. It's one of the only teleconnection patterns where we have this monthly to seasonal predictability. So there is really heavy reliance on it for the longer range climate outlooks. When we're thinking about 3 to 6 months ahead of time, the main things that CPC is really relying on is if we're in some sort of ENSO state, if we're either in El Nino or La Nina, and the longer term trends. And so that's, whenever I'm talking to partners, that's one of the things I really hit home, is that this is a really big factor in our winter outlooks because it's one of the main things we can see right now. Whereas there's plenty of other climate patterns, and we know that, just they have much shorter predictability and definitely not as reliable. So that's why El Nino ends up being such a significant player in the long range outlooks. So of course, then, what are we looking at for this winter? Again, Jeff's going to go into more detail on this winter specifically, but typically what we see with that weaker Walker circulation, with the El Nino conditions, we normally see the Pacific jet stream shift a little bit further south and becomes a little bit stronger. So that's going to favor the southern tier of the U.S. for a much more amplified storm track, wetter, colder, much more active. We then also see that the polar jet stream shifts a little bit further north, leading to less storminess and milder than average conditions across the northern U.S. Again, this is typical. It should be noted that up here in North Dakota, we do have winter storm warnings out. But this is winter, so in the fall can be a little bit different for us. And again, this is just the typical pattern that we see. But when we look at, individual ENSO events, you can see why this is the typical expectation. These figures are from Brian Brettschneider from Alaska Region Headquarters. These are available on the National Climate Services program page. Highly recommend them. They're really useful when you're talking to partners and the public. This is the average temperature departure during November through March in El Nino years since 1940, which there have been 29 since 1940. And you can see it's nice because he's got all the different regions highlighted. So you can see for Central Region that certainly some differences from north to south. If we're looking at the Northern Plains, the Dakotas, Minnesota, into Wisconsin, that is in kind of this +1 to +3 degrees Fahrenheit average temperature departure during the cold season. Again, with what we just looked at with that northern, the polar jet stream shifted north, favors a little bit milder across this part of the country. By the time we get a little bit further south, anomalies definitely weaken. By the time you get south of that, you're in the 0 to +1 range, and then further south of that, in the southern part of Central Region, we're in the 0 to -1 degree range, especially a little bit colder maybe as you're getting into Colorado and into parts of western Kansas. Yes, I'm sure those can be shared. Either Jeff and I will share those at some point in the chat. So those are the typical average temperature departures. Then we start to look at average precipitation during December through February. And you can see again, some typical trends. A lot of the region is in this yellow shading, which is 75 to 95% of normal. It's maybe not the most spatially consistent for some places. A lot of the yellow shading mixed in with the gray shading, which is actually close to normal, 95 to 105% of normal. Then there is this wet signal across the Central Plains. This Nebraska, Kansas area actually skews a little bit wetter than normal. Again, if we're looking at all those El Nino years combined, they're in the 105 to 125% of normal precipitation. So some trends there with this wet signal Central Plains, most of the rest of the region either near normal or skewing a little bit drier than normal. So then you move on to the percent of average snowfall. Again, this is for the entire season, and it also, as we've been telling our partners up here, can be really dependent on those temperatures. That if we're seeing those above normal temperatures, we might have below normal snowfall, but we could still have that near normal precipitation if we're just getting more rain and mixed precipitation events compared to just snow. But some slightly more consistent trends here. Again, we're looking at the Northern Plains, pretty widespread signal of skewing towards below normal snowfall. This yellow shading is the 75 to 95% of normal. The Dakotas, Minnesota, Wisconsin, over here into the Midwest, much of Michigan, Indiana, into Kentucky and Illinois. So that's pretty consistent there. Meanwhile, if we're looking at the Central Plains again, where it was already skewing a little bit wetter, also skewing towards above normal snowfall for places in Colorado, Nebraska, Kansas, into Missouri, that 105 to 125% of normal snowfall for the season. So again, this is blending all the years together. Sometimes you can get, a really strong signal kind of canceled out a little bit if you've got the opposite anomaly. So this is just a general, but it is a good starting point. So I really like these figures. These are also available on the Climate Services webpage. These are from created by Tom Dang, who is the SUE at the Tucson office. I've already used these this year because I think they're great at illustrating why we have a typical pattern, but why that doesn't always come true. And especially if we're focusing on these strong El Ninos, because again, that is what we're favored for with this event. You can see that we typically get warm across pretty much all of Central Region. It's interesting to see how far south that warm anomaly can extend. But again, that's not always the case. You can see there were some cold years in there, and there are some years that are kind of, evenly split one way or the other, this 1972, 1973. If you start looking at the moderate and the weak, especially, you can really see some interesting signals showing up in there. But again, there's the typical pattern that we see and the typical impacts from an El Nino, but it's never a guarantee. Here's the same thing for precipitation, which is also, really interesting to look at. That a lot of the times, especially in the Northern Plains, where we're expecting a little bit drier compared to south, where you're expecting a little bit wetter, that shows up a good portion of the time. Precipitation can be a little bit harder to have really widespread, signals for 1 year, where it can be a little bit spottier compared to temperature anomalies. But again, there's some years that look completely different. So it's, we know that it's not always it's not the only factor going in. It's just the main one of the main factors that we can see at this point in time as we're kind of preparing for winter. So another thing that can be really useful is not just looking at December, January, February, but instead looking at early winter, late winter, kind of including those transition season months, because I think for a lot of places you can see very different signals at different points in the winter. You know, if you're blending the entire winter together, you might not have a really strong signal, but if you look at early winter versus late winter, you might pick up on some things. So these are the increased risk of warm or cold extremes. So the first one on the left is for November, December, January, and you can see that during an El Nino, there's a really strong signal for a good portion of central region, especially this north central part of the CONUS that has a really increased risk of warm extremes. So this is, you know, late fall through much of the winter, those first 2 months of meteorological winter. The rest of the region is really, you know, not tilting one way or the other. If we then switch and we look at February, March, April, so late winter into the spring, certainly a different story where you still have this, you know, potential for warm extremes, North Dakota into Minnesota, Wisconsin, and Michigan. But then as we look towards the southern part of the region, you know, there is some hints at maybe an increased risk of cold extremes. It's not a super strong signal, but it certainly is different when you're compared to when you're looking at earlier in the season. So again, just splitting the season up sometimes can reveal things that you would not normally see by just looking at December, January, February. This is the same thing for precipitation extremes. Again, November, December, January on the left. Interesting to see this really dry signal across kind of the Rockies region into maybe the Western Dakotas. Then you see this northwest, southwest and northeast oriented kind of wet signal, which I thought was really interesting. Again, that's for kind of the first half of the season. And then it becomes very different the second half of the season where we've got a really strong dry signal across northern Minnesota into all of Wisconsin and more of that Midwest region into Illinois, Indiana, and Michigan. And then if we're looking at the southwest part of central region, Colorado, Nebraska, Kansas, there's a really strong signal for an increased wet extreme. So again, this can be really useful information to your partners, especially if you know, your cold season's not just December, January, February. If instead, you know, it's more of a November through March sort of thing. It could be even longer if you're further north like me. But this can be really, it's a little bit more nuanced, but again, it can provide some added context to your partners, especially those, you know, in agricultural heavy places. This can be really useful information. Just to look at the most recent strong El Nino back in 2015, 2016. Again, there's no guarantee we're going to see this. This is just what we saw with the last strong El Nino. This is the average temperature departure for me November through March. So again, that entire cold season, really warm across, you know, basically the entirety of central region. By the time we look at precipitation November through March, some wet signal across the Iowa, Wisconsin, especially down into Missouri, a little bit wetter than normal, a little bit drier than normal across the Dakotas and further west of there and parts of Colorado into Kansas. But then interesting to look at the accumulated snowfall departure, where again, you know, you can see a different sort of signal because we were so warm that even these places that got much more precipitation than normal, that they maybe were not getting that snowfall. So again, emphasizing to partners, especially if they're concerned with drought conditions, if you're not getting the snowfall, you could still be getting the precipitation. Those are some regional trends that you can pick up on. Another question we get a lot, you know, if there's no strong influence from El Nino in your area, especially if you're, you know, on the winter outlooks, if you're in this equal chances, it can be really hard to communicate. And one of the things we try to do is not only looking at, you know, areas outside of December, January, February, where sometimes if you have January, February, March, there can be some sort of signal there, either in the official CPC outlooks or just in ENSO signals or things like that. Also focusing on long-term trends. There's some really interesting trends to pick up on with the new set of climate normals that we got, and that's what these figures are. These are comparing the old climate normals to the new climate normals. So you can see over here on the far right, this is the trend for all of winter. And it's not too strong, you know, maybe a little bit of a cool signal across the northern plains, but a lot of the region is, you don't see too much of a sway one way or the other. If you break it up month by month, this is where it gets really interesting, where January, there's a really strong warming signal across most of the region. If you look in December, there's a little bit of a warm signal across kind of the Midwest region. And then you switch to February and there's a really impressive cold signal across the majority of the region. So again, these are things that it might not seem super important, but it's a little bit of nuance that you can give to your partners, if they have interests in, different months, that sort of things. But again, if you've got that equal chances or not a really strong trend in the base outlooks or because of El Nino, look at the temperature trends, both seasonal and monthly. You might find some really useful information there. And I can see Jeff is putting a bunch of stuff in the chat. That's all going to be really useful if you're into the climate world. A lot of good resources there. So again, looking at these for precipitation, this one again can be a little bit harder, but if you're in an equal chances, you can look at the long-term trends for all of winter. Certainly some signals to pick up on here. And it was interesting looking at the month by month where, December and February look relatively similar, especially if you're kind of in this Ohio Valley region. But then January, really not much of a trend one way or the other across pretty much the entire region. So again, those can be, some nuances where December, obviously a really big travel month with the holidays. If you're, skewing towards, a little bit wetter than normal in that month specifically and not just the entire winter, that can be useful information. Even internally, if you don't share it with your partners, it can be just good for your office to know that these are the longer term trends. Of course, the transition seasons, I talk about these a lot, but these are really, really important. Again, especially if you're, lots of farmers and ranchers in the agricultural community, we get a lot of questions about spring. We're already getting them in the fall. They're finishing up harvest. Knowing what's coming is really important to them. With an El Nino, it's a little bit tricky this year. Typically, a lot of the region skews a little bit colder than normal in the fall with the El Nino influence, but you can see that the long-term trend is warm. And I think this fall, we weren't quite sure what was going to end up dominating. I know for North Dakota, the long-term trend has been winning out for most of the fall so far. Of course, now we're getting that pretty significant cold push moving through the region through the next week or so. But again, these transition seasons, if you've got equal chances, it's probably because these signals are canceling out and the CBC forecasters aren't quite sure which one is going to be dominating. We're also seeing that in the spring a lot where, that warm anomaly, especially north central, typically hangs out a little bit longer into the spring. But there's a pretty significant cooling trend in the spring. So again, those nuances of, this is what we've typically seen with El Ninos, but as we kind of continue on in time and we got those new climate normals and we're seeing that strong trend, what we've historically seen with El Ninos, especially if you're blending all of them together, might not be happening with the most current El Ninos. So again, just things to pick up on. You never have to focus on just December, January, February. You can extend it into those transition seasons. And of course, with the transition season, spring severe weather season is certainly something to be paying attention to. And some good news, I guess, on that front with the El Nino influence, actually skewing towards a little bit less frequent severe weather in the spring, especially if you are looking at hailstorms down in the Kansas and Missouri area, certainly skewing towards less frequent. The subtropical jet is normally more zonal, so you're getting less meridional flow of that Gulf moisture coming in that you typically see with the La Nina influence. So again, this could be some good news for those kind of the southern part of central region as you're looking ahead towards the spring severe weather season. So just some quick communication tips before I finish up. Got a couple more slides, but some things we've learned over the past couple of years is that ENSO impacts are never a guarantee. Even if there's increased risks of some impacts. So, using verbiage such as favored, leans, tilts, and also noting that stronger events, like if we do end up with a strong El Nino like we're favored to, doesn't necessarily mean stronger impacts. It's just more likely to see the typical pattern. You always want to be summarizing your expectations in plain language. Sometimes we can get a little wordy and a little sciencey, but you just want to address it. If your partners aren't getting that information from you, or the public's not getting that information from you, they're probably getting it from somewhere else. So sometimes you can really tame the hype just by talking about it. Even if you don't think you have a whole lot to say, or you've got equal chances and there's not really strong trends, even addressing it is going to go a long way. Of course, a reminder, you don't want to attribute specific events directly to El Nino. If we've got an extreme, attribution studies can be done to estimate if and how much El Nino contributed. But sometimes, you can maybe get trapped with that question of, oh, was this extreme event caused by El Nino? And you never want to attribute a specific event directly to the El Nino. So for some best practices, utilize the winter outlooks and share that information with your partners. Hosting webinars, with the release of the winter outlook, finding local data for similar ENSO events to compare. You never want to forget about fall and spring. That transition season information is really important. We had our webinar last week, and we actually got asked to do a midwinter update. So I think as we're, as the Weather Service as a whole is expanding into this subseasonal to seasonal timeframe, we're finding that there's a lot more desire for the information than we initially thought. I know personally, I was pretty surprised that we had that request right off the bat, but at the end of our webinar, someone was like, a local emergency manager was like, can we please get a midwinter update to see what you're thinking. And again, especially in states where, agricultural heavy, the spring plant season, all that sort of thing is really important. They want that information. And as we kind of progress, we're getting better at knowing that information. So sharing that information is really important. My last tip, just make sure that you're using the correct source for ENSO years. Sometimes it can be a little tricky, especially if you're focusing on a specific strength. Again, this is also available on the Climate Services webpage. So this is all there. If you've never looked at it before, highly recommend. There's a ton of great information sourced from across the country on there. So I would recommend going there for your ENSO years. And then like I said, this presentation will be linked on that webpage. With some just additional resources. The ENSO blog on climate.gov is great. The Climate Services website, the Central Region Climate Services website, lots of great information on all of these websites that I would highly encourage you to look at. That is all I have. We're gonna take questions at the end of the talk, since Jeff and I's talks are pretty similar. So with that, I am going to stop presenting and I'm going to turn it over to Jeff.
Thanks, Megan, for the great talk. As Megan talked about, this is a project that the Central Region's subseasonal to seasonal resources group has been working on. Mine is sort of similar to what we've done in the past couple of years, and I'm going to start presenting it here. Okay, should be able to see this, and if I start coughing, I apologize. I've been battling a cold over the last 2 weeks, so hopefully I don't have the coughing fits here. The winter outlook, past years we've done it in PowerPoint. This year we decided to do it more in Google Slides, so that was a change from what we've done in the past. One thing we do ask, if you do use it, is that you go up into the top here under File, and then turn around and make a copy. That's one thing about both our things. So if you do editing and everything else, it's in your own copy. So everyone gets a clean copy there. Another thing I will suggest as we go into things is these are all as being Google Slides. You can edit things fairly easily through it. One of the things down on the lower right is you can put your office in there fairly easy. So under View and under Theme Builder, and if you go to the second slide, you can just basically type in your office easily in the bottom here. So it's fairly easy there. And then just go back out of your slides and it should be there and all your slides there. One thing that we do have here, and we're going to keep this updated as far as the main link we'll have there. I'll be changing these slides out, but if they're not updated to date, you can slide this over a little bit. And we have all the different seasonal outlooks that are available. The bottom ones are the ones to use in October. The top ones are to use in November. But we'll slide those over and take care of that for you. But if you've downloaded the copy and you just want to turn around and don't want to download it again, keep what you already have, then you can do it that way. Other things that we do have, there's two different ways of updating images. One is under extensions and then go under app script. And under app script, then you go into this update images.gss. You can do that, and then you just hit run, and that'll update your images. Another spot you can update your images is up on the sorry about this. You can also update your images under update images up on top. So those are just a couple side notes as far as what we're doing here. I'm going to start the presentation here. This is Granddad's picture of Granddad's Bluff in La Crosse, showing the snowy scene for us there. You can update anything in yellow there. That's where your issued office and contact information is. So we'll start going into the presentation. I'm going to start the presentation here as far as the slideshow goes. And we'll run through the presentation. So these are the upfront takeaways. This is the first slide of the presentation. Just goes over the CPC outlooks, for example, showing the above normal temperatures across the northern half of eastern parts of central region. Is above normal temperatures primarily there. Do have a rare near normal there. If you look in Colorado down to the Arklatex, you can see a near normal temperature over on the upper left image, or sorry, upper right image. And that near normal is the first time it's been used in a monthly or seasonal outlook since December 2007. So it's the first time. It's very rare that they use these in seasonal or monthly, but they felt this year was a reason to use it for this one. And it was for the January through March 2008 presentation outlook for seasonal outlook. And they had near normal across the northern half of the country, basically from the Pacific Northwest into the Great Lakes, and the rest of the country was above normal. So sort of flip off this one here. The reason why they sort of went near normal was when we went back to the 2015-16 El Nino, there were some issues with that one where it just didn't materialize the way that we sort of expected it to. And the cooler temperatures actually, and even the cooler temperatures actually started to occur later parts. Typically, we see our impacts a lot of times more in the February into March time periods. So across the southern U.S., there was a not verifying the cold really well, especially in December through February time period here. So when they looked at the guidance and everything else, a lot of the models actually were pointing towards near normal. A lot of the statistical tools were all pointing towards near normal. So they ended up going near normal, at least for the December through February time period for temperatures in that area. Now, as far as seasonal precipitation, we're looking for drier than normal from the Pacific Northwest up into northern Minnesota and then down into the Great Lakes. As far as that goes, across the southern parts, as far as Kansas goes and Colorado, and even parts of Missouri, we're looking for a shift towards above normal precipitation in those areas. Again, CPC winter outlooks, winter forecast only showed the most likely outcome where there's a greater confidence. But again, this is only one possible outcome because there is chances for equal chances there on the shift to probabilities, and also the other probability, the lower one, will also show up too. One uncertainty for this winter is El Nino is not going to be the only player this year. Temperatures could be highly variable throughout the winter. Snowstorms will occur at times this winter. However, the frequency, number, and intensity of these events cannot be predicted at the seasonal time scales. This is the next slide, the second slide of the presentation. We actually go into the rationale between why CPC went towards what they forecasted. The first 5 bullets or so deals with the things that came out of the monthly ENSO diagnostics discussion. So, for example, expecting this to be a strong one with 75 to 85% chance from November through January that we'll see at least 1.5 degrees centigrade above normal seasonal sea surface temperatures in the Nino 3.4 region. The last one that we saw that was this strong would have been 2015 and 16. And there has been some other strong ones, 57, 58, 72, 73, 1982, 83, 91, 92, 97, 98, and 2009 and 10. So there's been several other strong ones since 4950. There's a 3 in 10 chance that this could be historically strong. Those would rival the 2015, 16, and 1997, 98 ones as far as El Ninos, and also the 1982, 1983 El Nino. Stronger El Nino events increase the likelihood of El Nino related climate anomalies, but they do not necessarily equate to strong impacts locally. So as Megan was talking about, your area may not be impacted much by El Nino at all. You're more impacted by the North Atlantic oscillation. Climate trends could also be impacting your area more. So those are more important things to be talking about if you're in an area that's not necessarily impacted by El Nino. El Ninos typically peak around December with the greatest impacts during our winter and spring, especially the latter parts of winter and into the early parts of spring. They also looked at the recent temperature and precipitation trends. Those are, with exception, when you don't have the El Nino or La Nina, those take the higher precedence as far as trends, as far as looking at the forecast there. Another thing that that was discussed was the lack of snow across Canada and Siberia. This can impact some research that was done by Judah Cohen, basically found that there's some sort of relation with above normal snowfall that can actually affect the Arctic oscillation. There is some questions. We're not have all the connections basically from the troposphere up to the stratosphere and back. There are some connections that we're still missing a little bit, but that's one thing that is looked at a little bit as you're going into winter. In addition to the ongoing El Nino, we have a strengthening positive Indian Ocean dipole taking place. And I'll go on that a little bit. And so I'm not going to go over the slide too much. This is what Megan was talking about. This is included in the slide package, talking about the various things that go with El Nino to explain it to your partners, what's going on a little bit here. So you can see everything else. One thing that we didn't mention in Megan's discussion was that the polar jet stream and also the subtropical jet or the Eastern Pacific jet stream can phase along the East Coast during El Ninos, and this results in a greater potential of nor'easters along there, and possibly this could impact the eastern parts of central region, these nor'easters. Since we really don't talk too much about the Indian Ocean dipole that much, I figured I'd at least throw a slide here talking about this. This is not part of the slide presentation part, but the Indian Ocean dipole, basically, it's in its positive phase right now. So you have cooler than normal temperatures in the eastern parts of the Indian Ocean and the western parts of the Pacific. That would also influence the maritime continent a little bit. When you're in a strong El Nino or El Nino, you also see the cooler than normal temperatures in the western Pacific. So the two are sort of in phase of each other a little bit right now. You have warmer than normal water temperatures across the western parts of the Indian Ocean. So that rises up your increased precipitation, which would be usually more over the maritime continent, Asia, or there you'd see the increased convection more over the western Pacific. In the case of an Indian Ocean dipole, everything is pushed off to the west in this case. So there's your Walker circulation across the Indian Ocean being shifted. So that also goes. When these two are in phase, it can also impact the strength of the Madden-Julian oscillation. Which circulates the globe anywhere from about 30 to about 45 days across the globe. The circulation does occasionally affect the mid-latitudes. You can end up with wave trains starting in the tropics and then working their way up into the thing. It was very active last winter as far as the Madden-Julian oscillation. And it helped with a lot of the Pacific rivers that we saw in the western parts of the US, and then as far as where the jet was actually located too. So it also impacted there. This slide is Wheeler-Hendon diagram over on the left-hand side. You can see right now, this is the GFS solution, the GEF solution. A lot of the models suggesting that we are in phase 1 to 8, which is over the Western Hemisphere. And right now, as far as where we're located, so we're in phase 8 right now, going to phase 1, which would be more over Africa. Looking at the 200 millibar velocity potentials, green basically being enhanced areas of precipitation and brown being subsidence. You can see that the ENSO base state is there with the green showing up near the international date line. So just east of the international date line over to 120, you can sort of see the green area there. This started back in the spring, so we started to see the development of the ENSO base state. So that's where areas that we'd see enhanced precipitation. Recently, since the early parts of October, we actually started to see the Indian Ocean dipole really starting to show up. That's that brown area showing up between 160 and 120 east. That Indian Ocean dipole there is weakening somewhat the Madden-Julian oscillation. So as the Madden-Julian oscillation tries to go through the two more robust signals, the Indian Ocean dipole and also the El Nino base state, you end up with a weaker Madden-Julian oscillation coming through. However, one thing, a weaker Madden-Julian oscillation still has some impacts in the tropics. For example, just in the last 24 hours ago, Hurricane Otis, which is in the Eastern Pacific, actually strengthened from just sustained winds about 50 miles an hour to 160 miles per hour there. And that's a 110 mile per hour increase in just 24 hours. It's only second only to Hurricane Patricia back in October 2015. So just things that are affecting the weather right now as far as our climate goes right now. With a weaker Madden-Julian oscillation, it typically, the impacts stay near the tropics. And as the Madden-Julian oscillation strengthens and starts moving away, more away from the central circle in the Wheeler-Hendon diagram, you will actually see stronger impacts up into the mid-latitudes. And these can vary from month and even seasonally. Taking a look at the snowfall that I mentioned earlier, you can see that we've got below normal snowfall across much of Canada and across much of Asia there. And with having that below normal snowfall, that means basically the Arctic oscillation, the polar vortex is not necessarily being impacted by that snow potentially there. So that comes out of Judah Cohen's work there. And you see the above normal across Greenland. But typically we look more towards Siberian snowpack. Here's where we're looking at Siberian Eurasian snow content right now. And right now we're towards the lowest as far as for the month of October right now since 2014. As I said earlier, we also are concerned with the North Atlantic oscillation. This can impact the eastern portions of Central region. Even the Central Plains, Central and Northern Plains can also be impacted by the North Atlantic oscillation. So if you end up with a trough, it can result in high pressure building over Greenland, which results in a troughiness across the eastern and central US for cooler. And then also the polar vortex is another factor. As the polar vortex breaks down in winter, it creates more uncertainty in the outlooks. Going a little further out, just want to see how CPC was actually shifting their seasonal forecast a little bit. So as we moved into the January through March right now, the near normal is actually shifted. And this is basically looking back at what strong El Ninos have done in the past a little bit. So you see the near normal is now across southern parts of Kansas and heading down into Georgia, northern Florida. Still seeing the above normal signals for temperatures, shift in temperatures towards warmer across the northern US, and also the below normal precipitation shift there over the Great Lakes, and the above normal precipitation is starting to shift northward. One thing that trends have been noting is some wetness starting to move up typically in the latter parts of winter and into spring, up into Nebraska and Kansas and Colorado. So we see this enhanced above normal precipitation shift up into those areas. Going a little bit later, late winter into spring, the February through April time period, still see the above normal across the shift towards above normal temperatures across the northern US. The colder signals taking place across the southern plains there, so below normal there. A lot of that has to do with maybe the Arctic oscillation breaking down and coming down into those areas, leading to more coldness as the El Nino starts to break down, and then the Arctic oscillations also, the polar vortex is breaking down at the same time there. Again, the precipitation as we get in the spring tends to shift more and more in the trends up into the central and northern plains a little bit more. So as a result, we're seeing the above normal precipitation shifted up into those areas towards above normal. Some of Brian Brentshire's work, just looking at the 6 strong El Ninos, and now we're back to what's in the presentation there that we have. We just shared graphics showing how the variability of the strong El Ninos have been affected. I did not include the 1965-66 in this slide, so because it was strong going into the winter, and during the winter it was a moderate one. So I didn't include it in the graphics. So you can see some variability across the area as far as temperatures go. 5 of the 7 are fairly warm across much of the region. 2009-10 was one of the colder ones as far as strong El Ninos. As far as looking at the winter precipitation goes, some variability. The stronger ones did show some shift towards wetter than normal across the central plains up into the upper Mississippi River Valley. So there is some shift towards being wetter there. The eastern parts, basically the northern plains, and then into the from the mid-Mississippi River Valley up into the Great Lakes are tending to be drier during these strong events. And then looking at the seasonal snow, quite a bit of variability just because depending on when the snowpack breaks down, you'll see the El Nino breakdown or weaken a little bit at times, and some other oscillations will actually take over for a little bit. So you can see breakdowns where all of a sudden some other ones might become stronger and affect what's going across there. I won't go too much into these slides. I did include them for anybody who wants to use them that's in an area that's not necessarily impacted or also wants to just talk about seasonal trends and monthly trends as far as temperatures. Here's the average temperature trends, the average max temp trends, average min temps trends, and the precipitation trends across the central region. One thing I would suggest that you add at least some local information. I did leave some slides where you can actually look at this. I've actually included this slide, which lets you talks you through as far as making monthly summarized data through Examasis with just El Nino years. So you can actually go into your monthly summarized data, just choose the variable you're looking for, then choose the months that you're interested. If you're interested in from November through March, you can do November through March there. And then under the bottom one, you can actually drop down. It's sort of hidden there. You just drop down in there and you can select the years for El Nino. And I listed all the El Nino years here for your convenience. And that will just generate the table over on the right, which has all the years along with the amount of what your average temperature was for December, January, and February, and what the seasonal was. And then it does a max and min down there for you. So you can sort of give your partners a ability to see what's going on. In mine, I decided to just look at the moderate and strong El Ninos there. So I listed them off here. Some trends that I was noticing, at least in my local area in La Crosse, was that since 82, 83, we've been trending warmer with El Nino in our area. Prior to that, we saw quite a few near normals and belows. So there has been a shift towards warmer, and that's a trend that we've been noticing here locally there. Going a little bit at the precipitation trends, sort of high variability, not much in the equal change as far as the near normal, which is the white category for terciles. Yeah, the red terciles are above normal terciles. The blue is below, and I actually went back from 1940, 950, and then went all the way through current and broke up the terciles to look at this data, trying to find the trends. Seasonal snow here, even in snow seasons where there's little snow, you still have months where you see a lot of snow. The red one's showing the above normal terciles as far as snowfall goes. So, for example, back in 1963, 64 El Nino, we had 1 month, March, it was 17.7 inches of snow, and that skewed the number up to 32.1 for the seasonal snow. So you can sort of look and see, quick way of looking and see how things trended a little bit across your various areas. So it's just something to look at in that case. So these tables can be easily generated. Other tools that can be used is LCAT, the local climate application tool. Again, looking at the top image there, I'm looking at from 1950 to 2021. They're looking at the winter and only basic of the El Nino over on the left graphics there. On the far right of that one, you can actually see that if you looked at all the El Ninos clumped together, near normal tend to be more favorable in our area, but there's a statistical significant signal to the 90th percentile over on the below normal side. Now, if I look at the El Nino since 1985 to 2021, you can see a shift in the data more towards the near normal and above normal. Still have the statistical cold signal there. This time it's for less cold signal. I did include the November local temperature outlooks and November precipitation outlooks. So those are available right now. For my area, it's pretty much equal chances right now going. So, and then here's a review of the winter outlook for the various areas there. So this is the summary slide. Just talks about what's going on, what is what's expected, talking about the El Nino and what CPC is currently forecasted for the winter outlook. What is uncertain, talking about the strong Arctic oscillations, which has a predictability about 1 to 2 weeks in advance, so it's a little less there. Some uncertainty of snowstorms, and on the shorter time scales, less predictable ones such as the Arctic oscillation, North Atlantic oscillation. Those phases can also impact things, and also the Mendelian oscillation, which have a much shorter time frequency, and they can impact several times during the winter. The next CPC winter outlook will be issued on Thursday, November 16, 2023. And I would like to thank the Central Region Subseasonal and Seasonal Resource Project Work Group, Audra, Brandon, Corey, Megan, and myself for working on these presentations. And we'll answer questions now.
Yeah, I'd like to thank Megan and Jeff. That was a great job. If you have any questions, just put it in chat or raise your hand. Go ahead, Brian.
Yeah, thank you. Thank you, Megan and Jeff, for a most excellent presentation. Megan, if you see Mr. Johnson, tell him I said, hey, he was my photo buddy down here when he was here in Midland. It's still baseball season for my Texas Rangers, and so I'm going to throw a curveball out there, and that's the Eastern Pacific Oscillation. It seems like we've been stuck in a seasonally adjusted negative EPO for a while now. And if memory serves, and someone correct me if I'm wrong, that would teleconnect to a stronger Hudson's Bay low, which would put much of central region under cold northwesterly flow aloft. And I was curious if y'all had looked at the EPO, if my assessment was correct, and your thoughts on that. And thanks again, Guy and gals, for a great presentation.
As far as, I don't know if Megan wants to answer it or not. I will actually relay your question into to the CPC for a little bit there. It was considered a little bit, not necessarily this one, but it has been considered in the past. It didn't have as much of an impact in the 2015-16 one. That was more typical caused because the El Nino started to break down earlier than expected. And also we had a strong Arctic oscillation, which impacted the latter parts of that winter. So sort of some things that you were noticing there with the Eastern Pacific Oscillation, showing the stronger Hudson Bay troughiness there across the area and the cooler flow there. A lot of, at least in 2015-16, was more related to there. Has been looked at before. CPC hasn't noticed as much of a strong correlation. So it wasn't included in this outlook as much, but it's something that they do look at, and it is considered probably every winter as we go in, as far as when we head into the winter outlooks. So hopefully
okay.
that's
Yeah, Yeah, it does. I'm afraid that at least down here, it's going to shut most of the good moisture east of here, and we'll be still left in drought conditions. But anyway, y'all did a good job. I really appreciate the talk, and thank you very much.
Thanks, Brian. I actually had a little side note there. Our Sue Chauncey has been working on a local machine learning model using AI to try and predict what's going to happen in the winter. And he said that his machine learning did not like the EPO and that it actually reduced the accuracy. So for what that's worth, if you have more questions about that, you should ask him, because AI and machine learning is not my thing.
I might. Thank you.
Last call for questions. Seeing nothing, I'd like to thank everyone for joining, and thanks again to Megan and Jeff. That was a great presentation.